Swayam Prabha. Digital India. Educated India.
Okay, so we talk about the DES decryption. So we have seen the DES. So encryption was like this. So we have a plain text X. We apply a IP. We apply a permutation on this. Then we divide this into two parts: L0, R0, 64 bit, 64 bit, 32 bit, 32 bit. Then we are having a fiscal operation. So this is directly coming here, L1, R1. Then this is the function f, which is taking K1 as the first round key. Then we are XORing with this. We are XORing with this. Bitwise XOR, and this is the R1. Okay. So this is the first round, and then we continue this. So from here we have L2, R2, the same fiscal structure we are applying with K2, then we are XORing. So this way we continue up to we got L16, R16. So 16 fiscal cipher we are applying, then finally we are adding the IP inverse. And we got the Y, the ciphertext. So this is the plain. This is encryption of DES. DES encryption. Okay. Now the question is how the Bob decipher it. So Alice and Bob. So Alice wants to send a message to Bob. So they agree with a common key K, whose effective size is 56 bit. Okay. And Alice has a plain text M, whose size is 64 bit. So they decided to use the block cipher DES. So Alice is doing this encryption. So this is X. Alice is doing this encryption and getting this Y and sending Y to Bob. Now, so Bob has to decrypt it. So how Bob can get back the message? Decryption. That is the decryption algorithm or decryption procedure. So from this Y, Bob has to get back X. So basically Bob will apply this is IP inverse, IP, go back here. So basically we have to invert the fiscal cipher. So if we can invert the fiscal cipher, if we know how to invert a fiscal cipher, then we are done. So the question is how we can invert a fiscal cipher. So suppose we have a one round DES, which is basically a fiscal cipher. So this is basically we have L0, R0, and the output. This is one round DES. So this is L1, R1, and this is basically F. This is K1 for the first round, and we have XORing, and this is R1. So basically L1 is basically R0, and R1 is basically F of R0 K1 XOR with L0. This is the encryption. Okay. Now we want to decrypt. We want to make it reverse. I mean, so for decryption, our input will be L1 R1. So this is our input L1 R1. Now we need to get the L0 R0. So this is the decryption process we want to mount. Okay, so how we can do that? So from this equation we can say R0 is basically L1. So L1 is basically R0. Now we need to get L0. So, L0 is basically what? L0 is basically R1. If we XOR both side with f of this quantity, then the XOR this and this XOR will cancel out. So, basically we have R1 XOR with f of R0 K1. So, what is R0? R0 is nothing but L1. So, this is basically R1 XOR with f of L1 K1, that is it. So, that is R1. So, we just apply f on this with the value K1, the round key, and then we XOR with this with R1, bitwise XOR, and this is our L0. So, we got both L0 and R0 from L1 and R1. So, this is the one round decryption method of Feistel cipher. And the beauty of this cipher is we are not inverting this f, we are applying same f, because sometimes inverse may not be possible, because we in the f function we have s box, we have some permutation. So, that s box is also from 6 bit to 4 bit, if you remember DSS box, that is a 6 bit to 4 bit. So, that is also difficult to invert. This is one of the s box in. So, if we had to invert f, if we had to find out f inverse, then it may not be always possible, it may not be injective itself also. So, in that case inverse may not exist, then we have a difficulty, but the beauty of this structure is, beauty of this Feistel structure is, we really do not need to invert f to get the decryption process. So, we just apply f again and we get the cipher, we get the plain text. So, this is the inversion of the Feistel cipher. So, basically for DS we will apply this inversion process, and for that we need to have same keys, this K1, K2, K16. So, the Bob has to generate the key seedling algorithm and get the round keys, and Bob will do the same process to invert this Feistel cipher, and finally, Bob will reach here. After reaching here, Bob will apply the IP inverse to get the plain text X. Okay. So, this is the DS decryption. Now, the question is, we want to analyze this block cipher DS in the security point of view, how secure this DS is, whether we should I mean what type of attacks can we think on DS. So, that is called cryptanalysis on DS. Cryptanalysis on DS, or that is, or attacks on DS, something like that. Okay. So, there are some issues with DS. The first issue is it is not well documented, in the sense that the S box, main problem is with the, so this is the problems with DS, S box. So, they have given the just the table, a table, and a 4 by 16 table, 4 cross 16 table, 1 2 3 0 1 2 3 like that 15. So, they have given, say this is S1. So, there are 8 such S box. So, they have just given S box in a table and we need to do the table lookup, but how these values are coming, there is no proper explanation for that. So, that is one of the drawback of this, and another issue is with the key size. So, key size of DES is just 56 bit effective key size. So, that will enable us to mount the attack like generic attack like exhaustive search attack, time memory trade off attack. We will come to those attacks, those are generic attack. So, what do you mean by generic attack, non generic attack, we will discuss that. So, but before that let us talk about what are the attack model we have for the cryptographic cipher. Okay, so before that, so we want to so what are the attack model we can think of a cipher. So, first one is known ciphertext attack. Or this is called ciphertext only attack, ciphertext only attack. So, the point is Alice and Bob, they are communicating with each other and the ciphertexts are placed into the public channel, and the Oscar, the bad guy, I mean the attacker, we should not say bad guy, attacker is sitting here and Oscar has full control on this channel. So, Oscar is hearing all the ciphertext, all